Hi, I'm Everett. Welcome back to the shop. I finally have a chance to get back out here again. I know it's been a few weeks since I posted, so, as I say, getting things going again. I do have a job here that I brought home from the truck shop. I am still sort of part-time working for my buddy there, around chasing kids and trying to maintain sanity and a little bit of sleep. And what I have right now is a rear structure off of a Cat C15. What had happened was this thing had, I'm sorry I don't have pictures from before with the actual failure, but it had a flawed casting on one of the engine mounts. My buddy at work there, he wound up digging it out and having to grind out with a die grinder quite deeply in order to get all the porosity and impurities in that area. It's a fairly thick area on the engine mount. Not the lightest thing, so how about I face it to you guys instead of me? Yeah, there we go. There. So you can see all that area that has weld on it. Yeah, that area had to be ground out and filled and filled and filled and filled. So yes, it took a bit of time to do it. But considering the fact that these rear structures, I just for kicks and giggles looked this afternoon, to buy one new is about $3,000 US, and to get a used one's about a G note US. So by the time you get that to Canada, yeah, multiply it by at least 1.5, if not 1.6 or 1.7 for the cost by the time you get one north of the border here. So it was well worth the time for him to do some filling, and I'll do some machining. One of the challenges that I'm going to find here is just being able to mount it to the mill table and still have travel and being able to move it around to machine the flange itself flat again. But that just has to do with the size of the piece and the size of my mill. We'll figure it out. Hope you find it interesting. So what I've got so far here is as best as I can sort of place it on there. I'm going to start off with a clamp bolt through here through one of the flange bolts, and then I've got a clamp here going through the crankshaft rear main seal hole. I know this isn't super optimal at the moment because I'm clamping over air, as it's called. There's nothing solid underneath it. It's a fairly heavy casting as far as aluminum's concerned. I'm going to be taking light cuts. I am going to add a few more clamps once I get this thing squared up and set, but we're going to start by going with this. Now, as far as getting this flange here, I mean, I'm not going to be able to flip it vertically to be able to machine it in the flat position, so I'm going to have to do it vertically and side mill this part and clean this up with the end mill. But to get it started, I just got a 1, 2, 3 block here. I mean, this flange here is going to be a little chowdered as well, so it's going to be a bit of a line of best fit anyway. But what I've done is I've just sort of, with the nuts there loose, sort of bumped it to the point where I can get a square roughly under there. It might take a little bit of time to fiddle with this with an indicator. I'm going to indicate across here and get a line of best fit. There's a spot just right along here that looks like I should be able to get away with it. What I'm going to do is I'll do that first and then bring you back in when we actually start mounting up an end mill. It turns out that the actual flange here is kind of dished in this spot here, probably from some cookie wheeling and whatever in that spot. So what I've done is I've tried to get the line of best fit. This is as far as this will travel this way. I'm at the end of my Y. I will still be able to get a cutter just past the end of the workpiece, and I'll get it definitely past the end of this side. So what I've done though is I'll show you. Right now it's the needle there actually says 71.5-ish. As I slide this across, it drops as low as 59, so we got about 12 thou worth of dip. Depending on how easy this is, because then I come to cut, yeah, like I come up here and back to 70, 71-ish. Depending on how easy this is to cut, I'm almost tempted just to shave the entire surface. We'll see how it goes. And I do apologize for the lighting. I realize there's kind of some backlighting here. I never thought I'd have to do drapes in the garage, but I think I may have to get a curtain for this window for filming during the daytime. So anyway, that's as close as I'm going to be able to get it. I'm going to do a bit more clamping, see what else I can come up with to make sure it stays put, and then we'll load up a cutter and start shaving. So after a bit of a break, got back to this, and in the meantime I started thinking about things, and again, I really don't like clamping over air. So I had the brain of, wait a minute, I have a set of machinist jacks that Phil and Pierre gave me a few years ago. So dug them out, and I got one underneath here. This one here is close enough to the edge of the casting. It's a big casting, I think it'll be okay. And then I also cleaned out one of the bolt holes and put a bolt in over on this engine mount surface here so that I could clamp on that part as well. Again, we're going to take light cuts, is aluminum, and you know, realistically speaking, this surface here, it's kind of got a bit of a waviness to it anyway, so we're just going to go with line of best fit between this point and this point, shave that off to there so that the big flange will grab onto there and be reasonably flat. After that, we'll deal with this upper surface as a separate thing. Got the machine set to 1100 RPM. Bring the table up there, and see where we go from here. Let's see how much of a mess we can make. Oh, for Pete's sake. I didn't realize that camera was vibrating. All right, let's try this. See if this works any better. My apologies, that first pass was vibrating because of where the camera was mounted. I'm curious if this is going to start skimming. Yeah. Yeah, I just took a light skim off that end there. So I think we're going to take, say, 5 thou. Then we're going to do a climb pass all the way to the other side, just to clean that up. You know, I'm going to try something different here. You know, there is a little bit of a step here. I want to try something. I don't know if this machine's going to be rigid enough to do this. Worst case scenario, I draw file it. But I was given some cutters a little while ago by a good friend of mine, and I want to try this. As I say, worst case scenario, I use the manual milling machine on this thing and draw file it after if the surface finish is less than spectacular. But what we'll do is we're going to slow this right down, and I'm going to try doing a very slow pass over the whole thing. Worst case scenario, I draw file it. I totally get that this bit is way too big for this machine as far as length. I totally get that. And I will admit there are a few little chatter marks in it. Nothing I can't draw file out. It's just easier to at least call this a roughing pass to get it flat, and then I can always polish it later with a file, as I say, get it looking pretty. Doing it in a horizontal mill like a K&T or a Cincinnati, like that big Cincinnati that, or I guess it's a medium Cincinnati that Maddie has, certainly would have been a better option, but I don't have one. Yeah, for the needs of this, that'll be plenty. That'll be just fine. All right. Yep. You see a couple spots in where the cutter has a bit of a ding in the teeth in the flutes, but overall, that is going to work for what this purpose is. Again, I'm not cutting a cylinder head surface here. This is a flange to bolt an engine mount to, so if it's not got a super micro inch surface, it's not going to be the end of the world. I mean, I like to be perfectionist when I can, but sometimes done is better than perfect. Or trying to hit perfect anyway. So I do have a corner rounding bit here to try to clean this corner up at the end. I don't feel like readjusting this thing as far as the hole. I mean, trying to find the line of best fit between these two holes to skim that. I'm just going to freehand it after. So we're going to clean up the this excess weld here and then go from there. Now I'm not sure how well I do at James Kilroy's mill challenge because I really haven't messed with the mill much lately. Trying to do 2 axes at once. Okay, I think that's down to surface there. That's a little better. How do we spin it the right way? Well, honestly, yeah. The thing is, I also realized this this bit isn't exactly the same curvature as the radius up here. I might just clean that up afterward with a cookie wheel. Well, this is the engine mount I'm going to use as a guide for a template for where to drill and tap. And what I've got here are some drill guides that I had made a while back to do an engine mount. Well, when I did an engine mount on a 3406E that I had changed out a while back at the shop there, had to add a couple more bolt holes to the engine mount. So what we're going to do is, first off, so we're going to clean these holes out. I'm just going to run a tap in quickly on each of them. I have a tap socket set, but they don't go this big. One fascinating thing is that this 3/4 inch 10 tap uses a 12 millimeter square on the end. So, I mean, it doesn't bother me as long as I have a wrench that'll work on it. Yeah, got all the grunge out of the bottom of the hole there. Nice, that one's nice and clean. Yeah, hope the threads are okay. Seem to look okay. Oh, right. Is that the... Yes, that's the through hole. Yeah. Yeah, some of these have... some of the holes are actually through holes into the flywheel housing. That one is nice and clean. Now this hole here that we're putting in is not a through hole. So we need to figure out how deep it is. Oh, duh. How about I not measure the through hole? Twit. Okay. 2.06. 2.06. Okay. She sits like that. And yes, I realize this isn't super precision as far as to the thousandth, but that's okay. Try to find the line of best fit with here. Try to get you in the middle there-ish. For this application, considering the tolerances, I think it'll be okay. So basically now we're just using the mill as a big vise because it's held down. Now the thing is, this is going to be a fairly high torque situation here. I don't know if my old drill is going to be able to handle it as it gets to be a deeper and deeper hole. Or a bigger and bigger hole, I should say. There. There we go. I think we're to depth. Like I said, not the most glamorous or the most elegant way of poking a hole, but it does work. There we go. That was a pain, but at least it was easier than the last time I did it. Now, using a tap wrench in this situation would have been more preferable. However, I can't really get one in there. I have one big enough to do this, but I can't really get it in there. So, thankfully, across the corners on my tap will be grabbed easily by a 13mm 12-point socket. I'll probably edit a bunch of this just because who really wants to watch somebody stand there and hand tap a hole? And it'll feel really good to get this done because Steve's been waiting a while for it. My buddy with the truck shop. Oh, little, I don't know if I've mentioned this before. I think I had at one point, but this stuff here that's used to wrap, well, basically I get this stuff from doing brake chambers. They come with a long 5/8/18 rod that you cut to length, and this stuff is used to protect the threads. Well, you wrap your taps in them, and they work great for protecting them in the drawer. And the best part is it's free. Well, at least it was when I was working at the truck shop. I'm sure you could get lots from your local truck shop if you swung by and dropped some donuts one day. Donuts seem to be currency at heavy-duty shops, it seems. There we go. Like I say, apart from a little bit of cleanup on this little spot in there, which I think I'm going to do with the die grinder, just hand profile it, this thing's ready to go. One thing I did notice is that when I did tap this hole, built up a little bit of a burr on the very end. I mean, I know it's a good idea to chamfer the hole before you thread it. Sorry, Pierre, I couldn't get at it, but yeah. Take the burr off first. Make sure that the deburring didn't raise a burr. Clean that up a bit. I don't know, I think that'd be a bit ironic, creating a burr while deburring. There. Good enough. Great, this thing's done. I can clean it up, clean up the machine, and get it back to the shop. It feels good to get this thing done. It's been waiting for me for a while. So yeah, not really my most precision nor prettiest machining job in the world, but I mean, it's certainly better than it was, and it'll be functional enough that we can get this engine together and out the door at the shop. Just wanted to say thank you to everybody who still wants to come hang out with me here in my shop, as sporadic as it is. Thanks to all the likes, the subscribes, whoever wants to come subscribe. If you don't, that's totally cool. Thanks for coming to hang out. And thank you for all the comments. I appreciate the constructive comments, like the ones where people explain, okay, you could do this better. I'm all ears. I'm still learning at this sort of thing, and I think we all are till we stop breathing anyway. So it's one of those things where I do appreciate the help from everybody, suggestions and support and that sort of stuff. Otherwise, thanks again for watching. See you all next time.